whenever you're factoring, the first thing to always consider is greatest common factor, okay? Out of this one, you could pull out an x squared, and you end up with this. Now, that x squared plus 1, can I factor that more or not? This doesn't factor more. And if you write x plus 1, or x minus 1, x plus 1, or whatever you would write, you know, it would mess up the whole problem. That part does not factor more. Okay, so that's the factorization, that one. Is it really a hard factoring one? I mean, not really. It's just that, you know, if people think that this should factor more, you know, who knows what they're going to write. Okay, now, the next thing to do is decide how many fractions you're writing here. And I'll tell you, this is the most commonly messed up type of problem right here. And I will tell you that the ones on the quiz or the test are, one of them is like this. Okay, so you can look forward to having one like this. I can't remember if it's on the test or the quiz or both. But that x squared, that messes people up. There's 3 fractions here. If you put 2 fractions, you messed it up. Why are there 3 fractions? Okay, this one is not a repeated one. That x squared plus 1 is not a multiplicity of 2. Okay, if it was written like this, oops, I'm erasing the wrong thing here. Hold on. If it was written like this, x plus 1 squared, that's a repeated one. Okay, but that squared's in the inside, that's not a repeated one. This one is kind of disguised. Like if I had x plus 1 squared, you would say that's x, that's a linear and it's repeated. Well, that is like x plus 0 squared. So it's x and x squared. And you just do that every time there's an x to a power. You gotta do each power of that x. And then let's see if people remember. Okay, you yell it out. What goes on top of this x? A. What about this x squared? B. You don't put bx plus c because you don't look at that as a quadratic. That is a linear that has a multiplicity of 2, and so you write that. This one is definitely a quadratic. This one is cx plus d. We follow all that? Okay, so now the next thing to do is multiply by the common denominator. All right, so I go like this, go like this. Again, you don't have to think too hard about what the common denominator is because you already have the common denominator on the paper. What that is always the common denominator. And of course, this will cancel that completely, and you'll just end up with the top of this one. Now, I intentionally made a small mistake here. Why don't you go ahead and write out what you think and then see if you can figure out what I did wrong. I know some of you probably already can tell. So this cx plus d needs to be in parentheses. And you know that cx plus d is dangerous because the c looks like a parentheses to begin with. So if you don't put it in parentheses, you know, you'll think it's an x. And like I said, that happens a lot where people think cx plus d is x plus 1 in parentheses. All right. Are there any questions about what I just did there? Everybody feels good about this? Okay. Now we got to consider the shortcut. The thing about x plus 1, or x squared plus 1, you can't make that 0. There's no number that makes x squared plus 1 equal to 0. You can't do it. Is there any number that you think will be useful that will get rid of, you'd have to get rid of 3 of the 4 letters. Got anything? Go ahead. Yeah, so if you make x 0, you will just leave b, right? So x equals 0 will be helpful. Okay, so let's just think a step beyond that. If I make x equals 0, I'll find b. Is there any other value for x that will be useful here? No. So I'm gonna have to do systems on this problem. Okay. Now we might as well just find b. Okay. It's not gonna hurt us to find b. But we're gonna need to do a system no matter what. All right. So when I put x equals 0, I get 1 equals. It makes all of this 0. It makes all of that 0, and it just says b. Right? 0 squared plus 1 is 1, so I get 1 equals b. Okay, I got b. That's good. But really that wasn't as helpful as I'd like because I still need to find A, C, and D, and the shortcut's not going to work for those. Okay? So I'm going to have to multiply this thing out. So let's start doing that. I'm going to do this in 2 steps because, well, I don't know. I guess I don't need to do 2 steps. I can do it on 1 step. If I'm going too fast on any of these, let me know. If you weren't here yesterday, you might not know where this is going yet, but I'll explain. All I did right there is say the shortcut didn't work, and I took this and I just multiplied it out. Now I'm going to add like terms. So there's an x cubed here, an x cubed there. There's an x squared here, an x squared there. And there two don't add. Okay. So when I go to add the x squareds, I put this in parentheses. I say the coefficients are a plus c. So I'd say, if I knew what a and c were, that's the number that would go in front of x cubed. So a plus c goes in front of x cubed. And b plus d goes in front of x squared. And then there's no like terms on the other ones, so I kind of lined them up. Any question what I did so far? You may not know why I did it, but does anybody have any question about what I did? Okay, so if you were not here yesterday, you'll see why I did this. And if you didn't understand the last time, I think this one actually demonstrates a little bit better. This polynomial is this polynomial. Those are supposed to be equal. They have an equal sign between them. So what does a plus c have to equal? You guys tell me. 2. Because that's the number in front of the x cubes. Okay, I'm going to use a different highlighter here. And then the b plus d has to equal -4. And I don't like that pink. And the a has to equal 2. And the green doesn't really look. Let's use orange. Does that orange look orange? Yeah, that's okay. And then the b equals 1. And now it turns out, on this particular problem, that knowing that b equals 1 was not super helpful because I just found b equals 1 again, which is good news because if b equals 1 here, and then b doesn't equal 1 here, then something's wrong. But b equals 1, and I would have got that either way. Now this system is not the most exciting system in the world. It's actually pretty easy to work with, because I could do this without actually doing a matrix. Does anybody have any question about what I did so far? Okay. Now I want to explain to you how you would do this with a matrix for if the problem is more complicated than this. Because this problem, I could rip through this system in my head in 10 seconds. But let's just say what you would do if it was more complicated, okay? Don't write this down. I could put this matrix in my calculator. I would have A, B, C, D, and then what they're equal to. So it'd be 1, 0, 1, 0, 2, 0, 1, 0, 1, -4, 1, 0, 0, 0, 2, 0, 1, 0, 0, 1. Okay? Now, do I need to do REF on that to figure out this problem? No. But that's what you would do if the system was more complex than this one. Okay? We didn't do that on this problem either. On this problem, instead of doing one big matrix, we did two little matrices. It's just the way that one worked out. So it's not, mandatory every single problem you do one big matrix. The one big matrix will always work. On this problem, I don't need to do a big matrix. I already know B. I already know A. Okay? So then I could just say like, well, if A plus C equals 2, and I know A equals 2, then you guys tell me, what's C have to be? 0. If B equals 1, and B plus D equals -4, then what does D equal to? -5, okay? So I could do that system really fast in my head. Not every system is going to be like that. So just be aware of that. And this A could not have been 0. This B cannot have been 0. This C or this D could be 0, but they both can't be 0. So none of those should end up being 0 for the entire numerator. And that's not what happens here, so that's good news. And then we write the answer and we're done. So let me tell you how I made this problem up, okay? The way I made this problem is I wrote this down on a sheet of paper. I said, that looks like a good problem to do. And I intentionally made this a polynomial that I knew couldn't be 0. And I knew it couldn't be 0, which I knew would mean that we would have to use matrices, okay? So, that's how I made the problem up. I made this up. I multiplied it all out. It equals this I'm not multiplied it. I added it all together, and I knew it equaled that, and that's what I gave you, and then we took it apart. Okay, so it kind of helps to understand how the problems are created, to understand the math that's going on there. So what we're gonna do next week on Monday is we're going to just practice doing this and RREF, and then we're going to take a quiz on Tuesday. Okay? Let me turn